right, these are the My Math Lab questions for R7. This is what it prints off for me as a student, so your questions might look a little different, but it should mirror your questions, at least for the spring 2023 online course. So the first question says, when the numerator and denominator of a rational expression, when you hear rational expression, just think fraction. And I know it's confusing because the next lesson is on radical expressions. So those are similar words, but we're just talking about a fraction. Contains no common factors. The rational expression is in lowest terms. Factored form just means you've taken, for example, a trinomial and changed it to a binomial. Lowest terms means you can't cancel anything that is common to the top and the bottom. Like 2/8 is not in lowest terms because if you factor the number 8, actually, I like the number 4 better. Let's do 4/6. 4/6 is not in lowest terms because they have a common factor. You can divide them both by 2, or a better way to look at it is factor 4. 4 is just 2 times 2. My goodness, this is quite the start. All right. 4 becomes 2 times 2, and 6 becomes 2 times 3, right? In its most simplified form. Then you cancel out the common factors and you get 2/3. That would be its lowest terms. This would be factored form. You've factored it. When you cancel the common factors, it's the lowest terms. All right. Choose the rational expression that simplifies to -1. So for -1, as a fraction, you're either going to see it as a negative out in front, 1/1, or a over a. Let's call them a over a because we're using a and b. So -1 can be negative a over a or negative a over positive a, right? Because a negative divided by a positive is a negative. Or it could be a positive a divided by a negative a because a positive divided by a negative is a negative. Yeah. So those are the different ways that you can write a negative number as a fraction. So which of these simplifies to -1? What you want to do is think about so here we have negative a over positive a, right? But what if a was 2 terms, a plus b? Let's look at it now. -1 equals negative a plus b over a plus b, right? Or negative a plus b over a plus b, or a plus b over negative a plus b, right? That's that one. That's that one. That's that one. There's another way to write negative parentheses a plus b, and that would be negative, distributing the negative, sorry, negative a minus b, right? I distributed the negative over a plus b. Same here. We can distribute that negative sign, so we have a plus b on top, but when we distribute the negative sign, we have negative a minus b. So there are really 1, 2, 3, 4, 5 different ways to write -1 as a fraction if you have 2 terms on the top of your fraction and 2 terms on the bottom of your fraction. There's an even further step that they're taking it here, because here it's a plus b, a minus b, a minus b, b minus a minus b, a minus b, b minus a, b plus a. So 2 of our choices don't have any plus signs whatsoever, right? Here we had negative a, negative b. A is positive down here, A is and A is negative up here. B is positive down here, B is negative up here. But here we have A is positive, A is negative, A is positive. Okay, let's look at each one of these. What I want to do is decide which one of these shows -1. You need to show -1 by making either the top or the bottom negative, making the top the inverse of the bottom. But the example I gave was A plus B. I don't think that one of the examples with A plus B is going to work here. Because if you have a positive A and a positive B, to make it negative, you would need a negative A and a negative B. We don't have that. Let's talk about what we do have. So for number 2, choice A, we have A plus B over A minus B. This one is an inverse, but it's positive A and positive A. So that cannot be truly negative, right? To find the actual negative of A plus B, it would look exactly like this one. A plus B over negative A minus B. So it's not A, because it's terrible. A, B, B. It's not the first choice because the A's are positive in the first choice. Let's look at the next choice. The next choice is B. So we have A minus B. This is better. One is positive, one is negative. So for this to be negative on the bottom, we would need a negative A and a positive B. Does that make sense? For it to be truly negative, right, we would either need the negative out in front applying to everything, or whatever's on top, we need the opposite of each of those on the bottom. Positive A needs to be a negative A. Positive B needs to be a negative B. I don't think that's the case for B. Oh, it might be. Okay, so B starts with A minus B over B minus A. Excellent. The first thing I do is I put them in order. So on the top we have A minus B. On the bottom we have B minus A, so let's switch the order. Negative A plus B. This is the inverse of this. This is the inverse of this. So that's actually good. Yeah? Negative A over A is the inverse of A over A, or A over the inverse of A. These are opposites, these are opposites. So B looks okay. Let's look at C. C is A minus B, so same as the previous example on the top. And then the bottom is A minus B. No, that's just positive, right? This mirrors this perfectly. Positive, positive, negative, negative. So it's not C, it's not A, because A, in the first example, A mirrors A, positive and negative. So it's halfway okay for A. It's very okay for B. Nothing mirrors anything. Nothing is its inverse for C. And then let's look at D. For D, we have B minus A over B plus A. So they're in the correct order, but B is positive, 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 negative, positive. So again, D is just like A, where one term is correctly inversed, but the other term is not. C, neither term is inversed, right? Positive, positive, negative, negative. Positive, 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 positive. So those will not work. Negative, positive is good, but it's only the A's, it's not this half. Positive, negative is good, but it's only the B's, it's not this half. This is the only one because we have a negative B over a positive B and a positive A over a negative A. So I would choose the one that it's out of order, A minus B over B minus A, because if you put it back into order, you'll see that this one's positive, whereas that one's negative, this one's negative, where that one's positive. That's a hard one. Number 3, reduce the rational expression to lowest terms. So when they say rational expression, they just mean a division problem. We have 4t minus 12 over t squared minus 9. Good. I want to look for something I can factor out of the top term and the bottom term. 4t minus 12, it's not a trinomial that I can change into two binomials, right? But 4t minus 12, I can factor out, in fact, a 4. 4t can be divided by 4, and negative 12 can be divided by 4. 4t divided by 4 will leave me with t. Negative 12 divided by 4 will leave me with a negative 3. Because if you think about it, if you go back, 4 times t is 4t, 4 times negative 3 is negative 12. Good? Down here, t squared minus 9. What we're doing here is the difference of two perfect squares. The equation for the difference of two perfect squares, you might just want to memorize. Difference of two squares. So you start with a squared minus b squared, and that factors to a plus b multiplied by a minus b. Good? So in this case, a squared is t squared. So a is going to be the square root of t squared, because the square root of a squared is the square root of t squared. The square root of a squared is going to give me a. The square root of t squared is going to give me t. So a is t. And then b, same thing. B squared is 9. I don't want b squared, I want to find what b is. So I take the square root, take the square root. B is, the square root of 9 is 3. So where t, if we just follow this, t squared minus 3 squared, which is 9, t squared minus 9 equals a plus b times a minus b. Good? So t squared minus 9, because we know the difference of two squares formula, it becomes t minus 3 times t plus 3. Now, to get it into its simplest form, this is the factored form because we factored it. We want to cancel out, I should stop using that color because that color's up here. Cancel out anything that you are multiplying by something else that is common to the top and the bottom. T minus 3 is being multiplied by 4. T minus 3 is being multiplied by t plus 3. So those cancel out because they are common to the numerator and the denominator. So then we just have 4 over t plus 3 as our answer for number 3. Number 4 is 12x over 8x squared minus 4x. So you might see this and think that looks like that, right? I have an exponent squared minus something, right? But this, I know that t squared is a perfect square. If I take the square root of t squared, I'll get something I can use. If I take the square root of 9, I'll get a 3, something I can use. T and 3. It was easy to turn it into two binomials. However, 8x squared isn't a perfect square, and 4x isn't a perfect square. So instead, you maybe want to look at it like the 4t minus 12. Is there anything I can divide out of 8x squared minus 4x? $12x is just alone up here. 8x squared minus 4x, I can factor out a 4x. Right? Just like up here, I factored out just a 4. 4t divided by 4 is t. Negative 12 divided by 4 is negative 3. So here I have 4x. 8x squared divided by 4x gives me 2x. Negative 4x divided by 4x gives me a negative 1. So now I have factored 12x divided by 4x times 2x minus 1. Now, just like we did, 4 becomes 2 times 2, 6 becomes 2 times 3. We're going to do that to 12 because I think we can factor 4 out of 12. 12 is the factor 4 times 3 times x. 4 times x times 2x minus 1. Okay? What can we factor out? Up here, we factored out the t minus 3. Down here, we can factor out the x and the 4. So we are left with 3 over 2x minus 1. Good? We're not going to factor out this x because this subtraction means that this whole thing is one factor. So you would have to have exactly 2x minus 1 up here for it to factor out. All right, number 5, reduce to lowest terms, and we have y squared minus 16 over 4y squared minus 12y minus 16. This one is a difference of 2 squares because the square root of y squared is y. So that means that a is y. The square root of 16 is 4, so b is 4. The formula was a squared minus b squared equals a plus b times a minus b, right? A squared is y squared, so that means a is y. B squared is 16, so that means b is 4. So we have y squared minus 16 becomes y plus 4 times y minus 4. Good. Here we have 4, 12, and 16. I can divide out a number from 4, 12, and 16. I can divide out a 4. Wonderful. So I'm going to divide out a 4 here. So on the top for 5, on top we now have y plus 4 times y minus 4. On the bottom, I'm going to factor out a 4. 4y squared divided by 4 gives me the y squared. Negative 12y divided by 4 gives me a negative 3y. Negative 16 divided by 4 is a negative 4. Good. One more step. On the bottom. So we're going to keep the 4 outside. And we're going to think about what can y squared minus 13y minus 4 factor, factor into. I need to turn this trinomial into a binomial. I want two numbers that will multiply to equal c and add to equal b. So they need to multiply to equal negative 4, add to equal negative 3. I'm going to say it's going to be negative 4 and 1, right? So over here I write y, not x, just because that's a y. Y minus 4, y plus 1. On the top we keep it the same. Y plus 4, y minus 4. Now we're at the step where we can just cancel. So we're going to cancel y minus 4, y minus 4. Y plus 4 on top, 4y plus 1 on the bottom. There's nothing else you can divide out, right? This is not the same as this, and it's obviously not the same as the number 4. So there's no common factors anymore. That would be one factor. All right, so that's 5. Number 6 says reduce the rational expression to lowest terms. Number 6. x squared minus 11x plus 24 over x squared minus x minus 6. Look at it, make sure there's nothing you can factor out. If there's not, we wanted to put it into two binomials, right? So we need two terms that will multiply to equal 24 and add to equal negative 11. So we're going to multiply to a positive number, but add to a negative number. That means I'm going to use all negative numbers. -1, -24, -2, -12, -3 times -8. Oh, that one looks like it works, right? -3 and -8. So x squared minus 11x plus 24 becomes x minus 3 times x minus 8. Down here, we need numbers that will multiply to equal -6, but add to equal -1. It's a -1x. They're both negatives. So here I'm going to choose a negative and a positive factor, and hopefully and look for a negative factor that is bigger than the positive factor. So we have a -6, +1, -3, +2, right? -3, +2 will work. X minus 3, x plus 2. And you'll see that, okay, both of those, when I was looking for factors, they both use -3. So once you've done your easier one, you can kind of think, okay, my two factors are 3 and 8. If my term is -6, am I going to be able to use a -3? Yes, I am, and then those will cancel. So if you could see that, that's a way to do it. Those two factor out, and we just have x minus 8 over x plus 2. Good. All right, number 7, x squared plus 4x minus 12 over 2 minus x. So I already don't like this because I don't factor things that end up with 2 minus x, right? You put the x first and then the constant behind the x. So I'm going to change this. I'm going to flip the order, but keep the sign, okay? 2 minus x, just like back when we had b minus a, we changed the order, but we made sure that the negative stayed with the a, okay? It can go in front, but it goes in front with its minus sign. So this is 2 minus x, so that's -x plus 2. Good? All right. Over here now we need two numbers that multiply to equal -12 and add to equal 4. Right? So they multiply to a negative but add to a positive. So I'm just going to do a positive and a negative. 1, -1 and 12. -2 and 6. That looks good, right? 6 minus 2 is 4. So I'm going to say this is x minus 2, x plus 6. Okay? Here is where we need to use this, the -1, question number 2, the -1 question. So here you're looking at x minus 2 on top and -x plus 2 on the bottom. I don't want it to be -x plus 2. I want it to be x minus 2. What do? I say, I'm going to multiply just, I'm going to multiply my whole fraction by something that won't change the value, but will change the sign of this one, okay? I'm going to multiply it by -1. -1 on the bottom, -1 on the top. Multiplying anything by -1 times -1 is just multiplying something by 1. Multiplying something by 1 doesn't change the value. So, but what I will get is -1, or just negative sign, right, in front of x minus 2 times x plus 6, because I'm not really interested in changing that x minus 2, I want to keep that x minus 2, but I want this negative 1 to change this into something that looks like that, okay? So then we had the negative 1, and we're going to distribute it to the negative x plus 2, okay? So keeping all of that the same. Now on the top you have negative 1 times x minus 2, x plus times x plus 6 over, and I'm going to distribute that negative 1 now. So negative 1 times a negative x makes it a positive x. Negative 1 times a 2 is going to make it a negative 2. Okay? Now, because I distributed that one still exists. It's still up here. It didn't disappear, but I don't want to distribute it yet. I want to distribute this one so that these two match so that I can cancel them out. It's okay to manipulate things like this so that you can cancel something out. We haven't lost anything, right? We still have that negative 1. Now it's just negative 1 times x plus 6. Don't forget the parentheses so you can distribute the negative 1. Okay, those cancel. There's now nothing on the bottom. You don't need to put a 0. That would be wrong. It's just a 1, okay? And anything divided by 1 is itself, so the bottom is gone. It's no longer a fraction. Distribute the negative 1 and you get negative x minus 6. Or my math lab might even write it as negative x plus 6. Good. That's number 7. Number 8 says, I keep trying to make a pattern of like, that one's a dot, that one's parentheses, I keep forgetting, or a closed parentheses. Number 8, we have 5x plus 2 being multiplied by 3, and then we're going to subtract the quantity 3x minus 7, and then we're going to multiply all of that by 5 over what is written as 3x minus 7 quantity squared. Good. What you want to do here is write out that 3x minus 7 as 2 terms, because hopefully one of your terms on the top will be 3x minus 7, and you can get rid of 1. Now distribute very carefully. This 3, even though it's behind, gets distributed to the 5x and the plus 2. So another way to write 5x plus 2 times 3 is 3, 5x plus 2, right? So 3 times 5 is 15x. 3 times 2 is 6. Now, same thing here. The 5 is being multiplied to the 3x and the negative 7. So it's actually 5 times 3x minus 7. Remember, I'm just going to keep the minus sign and leave the parentheses because I don't want to do too much at once. So 5 times 3x is 15x. 5 times a negative 7 is a negative 35. Good. All right. My next step is going to be distributing that minus sign. 15x minus 6 minus 15x plus 35, right? When I distribute the negative to the minus sign to the negative, it becomes a plus 35. Down here, we still have 3x plus 3x minus 7 times 3x minus 7, right? Okay, let's simplify this guy. 15x minus 15x. Those are the only common like terms. 15x minus 15x, it disappears. Good. Positive 15x and negative 15x makes 0 x's. Negative 6 plus 35, 29. Negative 6 plus 35, positive 29. 29 over 3x minus 7 squared, because I know I'm not going to be able to, I don't have any x's, so that can just be left as is. Guys, I made a mistake. When I was distributing when I was rewriting 15x x minus 6, it should be a plus 6. So that is actually 41. See, just because you get it wrong doesn't mean you don't understand it. I get things wrong a lot. All right, moving on to number 9. Number 9 says, perform the indicated operation and simplify the result. Leave it in factored form. So we have 4x plus 12 over 3x to the 6th times x over x squared minus 9. So think about what you know. Think about what you're going to do with each of these, okay? 4x plus 12, I'm going to factor out a 4. 3x to the 6th, I can't do anything. X can't do anything. X squared minus 9, that is, again, a difference of two squares. A squared minus b squared equals a plus b times a minus b. Here, a squared is x squared, so a is x. B squared is 9, so b is 3. You in agreement? If you take the square root of a squared and the square root of x squared, you get a is x. Square root of b squared and square root of 9, you get b is 3. So here, I'm going to change that to x plus 3 times x minus 3. I said I would factor out a 4 here. So that's going to be 4 times x plus 3. Multiplication just means we're multiplying straight across. So I'm going to say times x. Remember, the further you have it factored, so we could say that this is 4x, or we could say this is 4x squared plus 12x, right? But the more you have it factored, the better odds that you're going to be able to cancel something on the bottom, okay? So that was that. That's that. 3x to the 6th, I'm just going to leave it alone. There are 6 x's, but I don't need to write them all out. And then x squared minus 9, we decided was x plus 3 times x minus 3. It asked us to leave it in factored form. So now I would just cancel whatever I can cancel. Obviously, we see that we can cancel 1x plus 3, right? It's common to the top and the bottom. Now on the top, I have 4x. On the bottom, I have 3x to the 6th times x minus 3. So these are all being multiplied, right? If I were to write this out further, it would be, and I'm just going to use one color, it would be 4 times x on the top. It would be 3 times x, but there are 6 of them, times the quantity x minus 3. Okay? I see one more thing I can factor out. I can factor out 1x. Okay? So now we have 4 over 3 x to the 5th times x minus 3. We had 4x over 3x to the 6th times x minus 3. That x and one of the 6 x's canceled out to give us 4 on top and x to the 5th on the bottom instead of x to the 6th on the bottom. Number 10, similar, multiply and simplify the result. So for number 10, what have I been doing? That? Sometimes. Not really. Not consistently. 14x minus 70 over negative 5x. Good? Times 10 over 105 minus 21x. So I'm thinking, I'm trying to factor things out, right? Trying to simplify the answer. I'm trying to factor things out. The more I factor things, the more easily I'll be able to see what factors out. So 14x minus 70, I kind of want to see if I can take 70 and divide it by 14. Because if so, then I can call this I can take both of those terms and divide them by 14, right? So that will become 14 times 14x divided by 14 is just x. Negative 70 divided by 14 we said is negative 5. Okay, so I want to start simplifying as fast as I can. Times 10. So that's 14 times x minus 5 times 10. You could even say times 10 times, you can change 10 right now to 5 times 2. You can change 14 to 7 times 2 if you want. All right, we're getting as factored as possible. Down here we just have negative 5 times x, right? That's what that negative 5x means, that we're multiplying those. 105 and negative 21. Let's see if 105 can be divided by 21. And it can. It's 5. Good? Sorry. And I'm going to change the order, right? Because over here I have x minus 5. Here I have 105 minus 21x. I want the x in front. I like x's in front. So I'm going to say times negative 21x plus 105. I want this to look like this. I got this because I divided 14x minus 70 by 14. What can I divide negative 21x plus 105 by? What can I divide both of those by to make sure I have a positive x and a negative 5? I can divide them by what will make negative 21x into x, dividing it by negative 21. Right? Let's see if that works. So again, I'm just going to bring it down because I don't have very much room. That same 14 times x minus 5 times 10, which we can also easily call 14 is 7 times 2. And then 10 is 5 times 2, right? So the most factored form of 14 is 7 times 2. The most factored form of 10 is 2 times 5. On the bottom, we have that negative 5 being multiplied by x. And then we're going to take that negative 21x plus 105 and divide out a negative 21. So times negative 21 times, when I take negative 21x and divide it by negative 21, I get an x. When I take 105 and divide it by negative 21, I get a negative 5. Okay, 21 I can factor, but we're almost there. So up on top we have 7 times 2 times 2 times 5 times x minus 5. On the bottom we have negative 5 times, what's 21? The most factored form of 21 is 7 and 3, right? 21 divided by 7 is 3, but it was a negative, so maybe it's a negative 3. That's more convenient. So it's a positive 7 and a positive 7. Times x minus 5. The negative 21 becomes a positive 7, negative 3, or just a negative. You'd even put the negative out in front here, okay? So again, 7 times 2 times 2 times 5 times x minus 5 over negative 5 times 7 times negative 3 times x minus 5. And it doesn't matter if the negative stays with the 3 or the 7. If we're thinking about a negative multiplied by a negative, it cancels out, right? That negative and that negative make this whole bottom a positive anyway. So I'm going to write it as a positive. 7 times 2 times 2 times 5. And you could change the order if that was bothering you. 7 times 5 times 2 times 2 times x minus 5 over 7 times 5 times 3 times x minus 5. What can I cancel? I can cancel those two, I can cancel those two, and I can cancel the 5s. So what I have left is 2 times 2 over 3, or 4/3. I keep checking my answers and I'm getting them wrong. I left out this x a long time ago. Times x times x. There should have been an x. Okay, see, everybody makes mistakes. Number 11 is 4x squared minus 3x minus 10 divided by 3x squared minus 8x minus 16 divided by 16x squared plus 32x plus 15 divided by 3x squared plus 7x plus 4. Good. So that's all division. I want to change it into multiplication. So remember, keep, flip, change. That's going to become 4x squared minus 3x minus 10 over 3x squared minus 8x minus 16 times, so we keep and then we flip this one. So this is now going to be 3x squared plus 7x plus 4 over 16x squared plus 32x plus 15. Good? Flipped those. It's not division anymore. Now it's multiplication. Now you're just going to try to factor each of these trinomials. Make sure you can't divide them by anything, but factor each of these trinomials into two binomials. Let's start with 4x squared minus 3x minus 10. Okay? 4x squared minus 3x minus 10. We want a number that multiplies to equal negative 40 and adds to equal negative 3. So we're going to need a positive and a negative number, and we need the negative number to be bigger. So 1 negative 40, 2 negative 20, 4 negative 10, 5 negative 8, right? That one looks good. 5 negative 8. So 4x squared minus 3x minus 10 becomes, 4x squared minus 8x plus 5x minus 10. Factoring by grouping, we look just at the first number, first group first. 4x squared minus 8x, divide them each by 4x. So we have a 4x. 4x squared divided by 4x just gives me x. Negative 8x divided by 4x is a negative 2. 5x minus 10. Divide them both by 5. 5x divided by 5 is x. Negative 10 divided by 5 is a negative 2. Sorry. So that first one, 4x squared minus 3x minus 10 becomes 4x plus 5 times x minus 2. Let's go on to the 3x squared minus 8x minus 16. So 3 times a negative 16 is a negative 48. So I need two numbers that multiply to equal negative 48 and add to equal negative 8. So we have 1 negative 48, 2 negative 24, I don't even know. 48. 3, negative 16, 4 and 12. 4, negative 12. That's a good one. 4 and 12. So now it is 3x squared minus 12x plus 4x minus 16, right? Those first two terms, 3x squared minus 12x, I can divide out a 3x. So it'll be 3x x minus 4. 4x minus 16, I can divide out a 4. And I get an x minus 4x divided by 4 is x. Negative 16 divided by 4 is a negative 4. Good. So now for the 3x minus 8 minus 16, cutting it close, sorry. It is now 3x plus 4 times x minus 4. That became that, that became that. Three x squared plus 7x plus 4. Here I'm going to need two numbers that multiply to equal 12 and add to equal 7, right? Both positive, so we can say 1 and 12, 2 and 6, 3 and 4. 3 and 4 make 7. So 3x squared plus 7x plus 4 becomes 3x squared plus 3x plus 4x plus 4, right? That first group, I'm going to take out a 3x. Sorry, it should be more like this. 3x, keeping with my pattern. So that's a 3x. 3x squared divided by 3x just leaves me with x. 3x divided by 3x is 1. 4x plus 4, I can divide out a 4. So that's going to be plus 4. 4x divided by 4 is an x. 4 divided by 4 is a 1. So this one, 3x squared plus 7x plus 4 becomes 3x plus 4 times x plus 1. And finally, I'm going to start a new piece of paper, number 11. That last one was number 11 continued. That last one was 16x squared plus 32x plus 15. Gosh. All right, what's 16 times 15? 240. So I need two numbers that multiply to equal 240 and that add to equal 32. 16. Close. Yeah, that won't work. All right. Oh, we could just use 16 and 15, right? 16 plus 15. No. All right, 240. trying to cut corners. 240 divided by 2 is 120. So it's 2 and 120. It's not going to be that one. 240 divided by 3 is 80. 240 divided by 4 is 60. 240 divided by 5 is 48. 6 is 40. 8 and 30. Getting closer. 10 and 24. 12 and 20. Yay, we did it. All right, 12 and 20. So that now becomes 16x squared plus 12x plus 20 plus 15. If we just look at 16x squared and 12, I can factor out a 4x. And I get 4x times 4x plus 3. 20x. 20x and 15, I can factor out a 5. So it's plus 5. 20x divided by 5 is a 4x. And then 15 divided by 5 is 3. So that's 4x plus 3 times 4x plus 5 for that one. So that will go right here. 4x plus 3 times 4x plus 5. That's for this one. All right, so what we have is, I'm going to rewrite it over here. And we're just multiplying, so we're multiplying straight across, right? That means we've got never enough space is what we've got. 4x squared minus 3x minus 10 became 4x plus 5 times x minus 2. So that's that one. It is being divided by 3x squared minus 8x minus 16, which became 3x plus 4 times x minus 4. That was that one. And like I said, we're just multiplying straight across, so I'm just going to make this a longer bar. I'm going to connect them. Good. 3x squared plus 7x plus 4 became 3x plus 4 times x plus 1. That's that one. And then 16x squared plus 32x plus 15 became 4x plus 3 times 4x plus 5. So we have factored it. We haven't simplified it yet, but we have factored it. So this is number 11 in factored form. Now you just want to look at the top, 4x plus 5, for example. You see a 4x plus 5 here, 4x plus 5 here. X minus 2. I don't see an x minus 2. 3x plus 4. I see a 3x plus 4 here. I see a 3x plus 4 here. X plus 1. I don't see an x plus 1. Down on the bottom, yes. X minus 4, no. 4x plus 3? No. So your final answer is x minus 2 times x plus 1 over x minus 4 times 4x plus 3. Okay, and they said leave it in factored form, so you don't need to do anything further. Number 12 is 6 plus 1 over x divided by 5 minus 1 over x. What I would do here is you have a fraction and then you have a fraction within a fraction. I would look at the inner fractions and try to get rid of them, okay? X is in the denominator, so if I multiply, 1 is being divided by x. If I multiply 1 by x, those will cancel, right? But because this is an expression, I have to do that to all terms. So 1, 2, 3, 4, all 4 terms. So I'm going to multiply that by x. I'm going to multiply this by x. I'm going to multiply this by x. And I'm going to multiply this by x. Okay, basically what I've done is we had 6 plus 1 over x over 5 minus 1 over x. And I said I want that x gone, so I'm going to multiply the top and the bottom of the fraction by x over x. So now I'm multiplying 6 times x plus 1 times x over x. On the bottom it'll be 5 times x minus 1 times x divided by x. So let's rewrite that better. I'm going to distribute that x. That 6 is now a 6 times x plus 1 over x times x. Divided by 5, distribute that x, times x minus 1 over x, and again, times x. So I'm just distributing that x. And I want to make sure that I didn't make this look like it was on the bottom of the fraction. This is 1 divided by x times x, or 1 times x divided by x. So that these cancel and these cancel conveniently, okay? What you have is 6x plus 1, because 1 divided by x times x is just 1. And down here you have 5 times x is 5x minus 1. Done. That's number 12, okay? 13, a little different. 13 is 1 minus 5 over 5 minus 4 over x. All right, for 1 minus 5 divided by 5 minus 4 over x, what we want to do is get, just like we did up here, get rid of the fraction within a fraction. So that fraction is 4 over x. To get rid of the 4 divided by x, I want to multiply by x. I'm going to do the whole bottom of the fraction by x. Anything I do to the bottom of the fraction, I have to do to the top of the fraction, because x divided by x is just 1. So if I multiply both the top and the bottom, I'm maintaining the value of the fraction. So nothing happened over here to 1. We just have 1 minus 5 times x becomes 5x on top. Down here, 5 times x, because we have to distribute that x, becomes 5x. Negative 4 times x divided by x just is negative 4, right? Those two cancel. So now we have 1 minus 5x divided by 5x minus 4. What we need to do now is make common denominators to one common denominator so that we can subtract. So here 1 is just 1 over 1, right? But this denominator is 5x minus 4. So what's the common denominator between 1 and 5x minus 4? It's 5x minus 4. So you want to take 1 over 1 and multiply both the top and the bottom by 5x minus 4. Yikes, what a horrible pen. So we're multiplying that by our 1 over 1. And then over here, it's like, oh, I should multiply it by 1, but that keeps the value. So this is really the only one we need to change. So that becomes 5x minus 4 over 5x minus 4 minus 5 over 5x minus 4. Now that they have the same denominator, you can put all of the numerator on top. So we have, oh, sorry, it's 5x. It was a 5x up here and I called it a 5 down here. So we have 5x minus 4 minus 5x. 5x minus 4 minus 5x over 5x minus 4. Now you just simplify. 5x minus 5x becomes 0, right? A positive 5x and a negative 5x becomes 0, and we just have negative 4 over 5x minus 4 as our answer for number 13. Number 14, let's see if I can fit it on here. Number 14 is x to the third divided by y to the sixth divided by x to the sixth divided by y squared becomes I think I'm going to flip it. Becomes x to the third over y to the sixth times y squared over x to the sixth, right? So then that's just x to the third, y squared over y, x to the sixth, y to the sixth. I'm just going to change the order. So now you just use the rules of exponents. X to the third divided by x to the sixth is just x to the third down here, I apologize. Y squared divided by y to the sixth is just y to the fourth down here. Number 15 is a nightmare. Number 15 says 1 plus c, or sorry, 1 divided by c plus 1 divided by d over c squared minus d squared over cd. Okay, so this is one fraction. I want to get rid of the denominators of the fractions within the fraction. This denominator is c, this one's d, and this one's cd. My common denominator is cd, so I'm going to take the whole bottom of the fraction and multiply it by cd. I don't know why I put it inside the parentheses there. So when you distribute it now, you have 1 divided by c times cd plus 1 divided by d times cd over c squared minus d squared divided by cd times cd. Good, let's cancel immediately. Now I have d, right? D times 1 is just d, plus c times 1 is just c, over c squared minus d squared. Let's change the order of c and d because I want it to look like this one. So now we have d plus c becomes c plus d over c squared minus d squared, which is the difference of two squares. So the difference of two squares says that this would be c plus d times c minus d. I keep wanting to write a word because such odd lowercase letters. I can cancel these, and what I get is c minus d on the bottom. If there's nothing on the top, you put a 1. All right, number 17. We're now 17, 18, 19, and 20. We're finding the least common multiple of the polynomials. So for 17, we have x squared minus 64 and x squared minus 2x minus 48. So x squared minus 64 is just going to be x. What's the square root of 64? 8. X plus 8. X minus 8. So those are the two factors of x squared minus 64. X squared minus 40 minus 2x minus 48. Multiply to equal negative 48. Add to equal negative 2. So that would be 2, negative 24. What else was 48? We already did this today. 16 and 3. 4 and 12. Ooh, 6 and 8. So that's going to be 6x plus 6, x minus 8. You don't need to write this one twice. So I would say the least common multiple of these two polynomials is x plus 8, x plus 6, x minus 8. Number 18, we have x cubed minus 25x, and we have x squared minus 5x. X cubed minus 25x, you can factor out an x and you get x times x squared minus 25. X squared minus 25 is like x squared minus 64. It just becomes x plus 5, x minus 5. X squared minus 5x, you can factor out an x and you get x minus 5. So I would say the common factors for number 18 would be x plus 5 and x minus 5. It's okay. Yeah, we covered them all. Number 19 says, find the least common multiple of 7x minus 21 and x squared minus 6x plus 9. This one we can factor out a 7, so it would be 7x minus 3. X squared minus 9x minus 6x plus 9 would be x minus 3 squared, right? So my least common factors would be, or least common multiple is 7x minus 3. For 19, number 20, 36x to the 4th minus 12x to the 3rd plus x squared. I can factor out an x squared and I'll get 36x squared minus 12x plus 1. Trying to think of what that would then equal. I think it would best factor to 6 and 6, right? So that would be 36x squared minus 6x minus 6x plus 1. So and then we're doing factoring by grouping. 36x squared minus 6x would be divided by 6x. Be 6x. 6x minus 1. Here there's no common factor, so it would just be 1 minus 1. Negative 6x divided by negative 1 would be 6x Positive 1 divided by negative 1 is a negative 1. So 36x squared minus 12x plus 1 factors to x squared times 6x minus 1 times 6x minus 1 for number 20. And then 6x cubed minus x squared, and then x squared. So that's the first part. The second part is 6x cubed minus x squared, so I can factor out an x squared and I get 6x minus 1. And then x squared is just x squared. So my list of factors from both pages would be that one and that one. Those are the only two. All right, 21. Perform the following addition and simplify the result. So we have x over 3 plus 4 over 3. Those have a common denominator, so we can just combine them over 3 and we have x plus 4. Good. 22. We have x squared over 9x minus 5 minus 1 over 9x minus 5. So it ends with x squared minus 1 over 9x minus 5, but they did ask us to leave it in factored form. This is the difference of two squares, so it's actually x plus 1 times x minus 1 over 9x minus 5. '23 is a bit more complicated. So we have 8 over x minus 1 minus 2 over x plus 7. Now you need to have a common denominator, just like 9 minus 5 here and 3 here. So I'm going to multiply x minus 1 by x plus 7. Anything I do to the bottom, I have to do to the top. Over here, I'm going to multiply it by x minus 1, because you'll see then on the bottom, all we have is x minus 1 times x plus 7. So the bottom is all set. Now I need to distribute that 8 times x plus 7 minus 2 times x minus 1. 8x plus, what's 8 times 7? I'm very bad at my 8s. 8 times 7 is 56. Minus 2x plus 2 over x minus 1, x plus 7. Now combine the 56 and the 2, combine the 8 and the negative 2, and you get 6x plus 58 over x minus 1, x plus 7. Make sure you can't factor out 58 divided by 6, 58 divided by 3, 58 divided by 2. So you can say that that becomes 3x plus 29 over x minus 1, x plus 7. All right, same principle for number 24. X over x plus 1 plus 9x minus 5 over x minus 1. These are not common denominators, so just like we did here, we're going to multiply the top and the bottom by the denominator on the other side, x plus 1 times x plus 1. Over here it's going to be times x minus 1 times x minus 1. Good. So on the bottom, we have x plus 1 times x minus 1. On the top, we have x times x minus 1 plus 9x minus 5 times x plus 1. Good. There's an addition, so we cannot just cancel them out, okay? This is now x times x is x squared, x times negative 1 is a negative x, plus 9x times x is 9x squared, 9x times 1 is 9x, negative 5 times x is a negative 5x, negative 5 times 1 is a negative 5. Good. X squared plus 9x is 10x squared. 9x minus x minus 5. 3x minus 5 over x plus 1, x minus 1. Good. Can you factor anything out? 10, 3, and 5? No. Can I multiply to equal negative 50, add to equal 3? I don't think so. Negative 1, 50, negative 2, 25, negative 5, 10. So I'm just going to leave it like that. So that's 24. 25 is a long one. Let me write it down. All right, for this one, you want to factor your bottom terms first. So x squared minus 3x plus 2 becomes x minus 2, x minus 1, right? Because negative 2 and negative 1 multiply to equal positive 2, add to equal negative 3. Here, x squared minus x minus 2 is going to be x minus 2, x plus 1, right? Because negative 2 and 1 multiply to negative 2, but add to negative 1. We just have x's on the top. Good? Okay, now you'll see that you have partially common denominator. So instead of saying I need to multiply x squared minus 3x minus plus 2 times x squared minus x minus 2, we're just going to multiply it by x plus 1. When I have it by x plus 1, then I will have all three of these. My common denominator will be these three factor binomials, okay? Here, I'm only going to multiply by x minus 1. Good? X times x plus 1 over x plus 1 times x minus 2 times x minus 1 minus x times x minus 1 over x minus 2 times x plus 1 times x minus 1. Right? Now I have the common denominator I was looking for, x plus 1, and we're going to leave it in factored form, so we're done with the bottom. X minus 2, x minus 1 is our denominator. Now I have x, I'm going to distribute it. That's x squared plus x minus x times x is x squared. X times a negative 1 is a negative x. Good. Bottom stays the same. X plus 1 times x minus 2 times x minus 1. X squared plus x, distribute that negative, minus x squared plus x. This and these cancel. X squared minus x squared cancels, and I just have 2x over x plus 1 times x minus 2 times x minus 1. Oh, sorry, you couldn't even see it. Grand finale. And that is it. Those are those 25 questions from my math lab.